Consider this. You're at a field about ready to start your first game of beer league baseball for the summer. For the warm-up, your friend offers you two bats, a comically short one and a regular size bat. Of course, you're going to choose the regular size bat, but then you begin to wonder, why would the length of your bat affect your performance in the game? This can actually be explained using the concepts of linear and angular kinematics and the impulse momentum theorem. Let's first consider linear kinematics. The term linear refers to the movement of points through the same space over the same period of time, and the term kinematics refers to human motion without considering external forces that may affect the magnitude and direction of the body. Altogether, linear kinematics refers to points moving in a straight line without consideration of other forces. So there are three important components to consider for linear kinematics. For the purpose of this topic, we will only consider the vector components. First, we have position, which represents displacement or the shortest path between the start and end of an object's position. Next, we have the rate of change of position, called velocity. This is found by dividing the change in displacement by the change in time in which an object is moving. Lastly, we have acceleration, which represents the change in velocity of an object. This is found by dividing the change in velocity of an object by the change in time. Now we can move on to angular kinematics. While this is very similar to linear kinematics, it is important to understand the difference. Rather than considering the linear components of an object's movement, angular kinematics considers the movement of points moving through the same angle at the same time. Essentially, this concept considers an object's movement around a center of rotation. Angular kinematics also have three important components: angular position, which is represented by theta, angular velocity, which is represented by omega and considers the rate of change of angular displacement, and angular acceleration, which is represented by alpha and considers the rate of change of angular velocity. So now we know what angular and linear kinematics are, but how are they connected and what do they have to do with baseball bats? To state it simply, these two types of movement are related on the basis of radius, which is the distance from the point of an object to the axis of rotation. When considering the angular-linear relationship, displacement refers to the change in angular position of an object, which can be found by dividing the arc length by the radius of rotation. Another important component of this relationship to consider is the tangential velocity, which is a linear velocity tangent to the angular pathway of a moving object. To find this, multiply the radius by the angular velocity. Note, this is a very important equation and will be used later. The last component of the angular-linear relationship is acceleration. For this, there are three kinds: tangential acceleration, which determines the magnitude of the acceleration at any given point; centripetal acceleration, which is the acceleration that keeps the object in rotation; and the resultant acceleration, which is a sum of the tangential and centripetal acceleration values. Now, remember when I mentioned the impulse momentum theorem in the beginning? Let's dive into what that is and see how it is relevant when considering the length of baseball bats. Impulse is defined as the force applied to an object over a period of time, or force times time, and momentum is defined as the movement of the mass of a working system, which is mass times velocity. Because of their effect of applying force over a period of time, momentum and impulse can be assumed to have equivalent values. So, with that idea and the conservation of linear momentum, if the two bats have the exact same mass, the bat that swings at a higher velocity will cause the ball to travel much further due to the increased momentum and impulse values. So now consider that equation for tangential velocity I told you to remember earlier, which was velocity is equal to the radius times the angular velocity. We know from the impulse momentum theorem that we want increased velocity because that increases momentum and impulse. And we can increase the tangential velocity by increasing the radius, which in this case is the distance between the point of contact of the ball on the bat and your hands. So essentially, increasing the length of your bat allows you to swing at a higher velocity, which in turn causes the bat to strike the ball harder, which causes the ball to travel further. So go ahead, pick that regular size bat and increase your chances of getting a home run in that game that absolutely nobody is watching.